Generators and microphones are two fascinating devices that convert different forms of energy into electrical signals, playing essential roles in many fields of technology and everyday life. To understand their functions, it is important to explore how they operate, what they generate, and how the output can be measured or visualized. Alternators and dynamos are both types of electrical generators, but they differ significantly in the type of electrical current they produce. An alternator generates alternating current, AC, which periodically reverses direction. Alternators work based on Faraday's law of electromagnetic induction, which states that a voltage, or electromotive force, EMF, is induced in a conductor when it is exposed to a changing magnetic field. In an alternator, a rotor, a rotating magnet, spins inside a stationary set of coils, known as the stator. As the rotor spins, the magnetic field around the stator changes, causing the electrons in the stator windings to move back and forth, generating an alternating current. Alternators are widely used in various applications, from power plants that supply electricity to homes and industries to car engines where they charge the battery and power electrical systems. Dynamos, on the other hand, generate direct current, DC, which flows in a single direction. A dynamo also operates on the principle of electromagnetic induction but uses a commutator, a mechanical device that reverses the connection of the output coil to the external circuit at appropriate intervals, ensuring that the current always flows in the same direction. In a dynamo, a rotor with coils of wire spins inside a magnetic field. As the rotor turns, the commutator switches the connections of the coil at the right moment to maintain the direction of the current. This device was a key component in early electrical systems, particularly before the widespread adoption of AC power. Today, dynamos are less common than alternators but are still found in certain applications, such as small-scale generators or devices that require a steady DC supply. To visualize the electrical signals generated by alternators and dynamos, an oscilloscope is often used. An oscilloscope is a device that graphically displays electrical signals, showing how voltage or current varies over time. When connected to an alternator, the oscilloscope displays a sinusoidal waveform, representing the alternating current's periodic rise and fall. The peaks and troughs of this waveform correspond to the maximum and minimum voltages generated as the rotor spins within the magnetic field. In contrast, when connected to a dynamo, the oscilloscope shows a steady line or a slightly pulsating waveform, indicating the continuous and unidirectional flow of direct current. Oscilloscopes are invaluable tools in electrical engineering and physics, enabling engineers and technicians to analyze signal characteristics, detect faults, and measure parameters like frequency, amplitude, and phase. Microphones, though different in purpose, also generate electrical currents but from sound waves rather than mechanical motion. At their core, microphones are transducers that convert acoustic energy, sound waves, into electrical energy. This process relies on a diaphragm, a thin membrane that moves in response to sound waves. When sound waves hit the diaphragm, it vibrates, causing a corresponding change in a magnetic field or electrical capacitance. For instance, in a dynamic microphone, a small coil attached to the diaphragm moves within a magnetic field, generating an electrical current through electromagnetic induction. The movement of the coil in the magnetic field induces a voltage proportional to the sound wave's pressure changes. In a condenser microphone, the diaphragm is placed very close to a backplate, forming a capacitor. Sound waves cause the diaphragm to move, changing the capacitance and generating an electrical signal that corresponds to the sound wave's frequency and amplitude. Thus, whether dealing with mechanical generators like alternators and dynamos or acoustic transducers like microphones, the fundamental principle remains the conversion of one form of energy into electrical signals. These signals, whether alternating or direct, can be captured and analyzed using devices like oscilloscopes, providing valuable insights into their characteristics and enabling their use in countless practical applications across many fields of technology and science.